misi yang satu, permisi kita bantu.
Tahniah, siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, Salam, Sejahtera, and good evening, everyone. Welcome to Pusat Tuisyen Akademi Youtuber with joint venture of eDelete Malaysia and Guru Malaysia. I am Mr. Peh. I am currently teaching at College Tingkatan 6 Tun Fatimah Melaka. I am the on-duty teacher for this week. For information, Akademi Youtuber Panitia Fizik is preparing for you 2 free online classes, which will be the Non-DLP group for Form 5 class at every Friday 9:30 p.m. And this week is presented by Cikgu Rosemawati, and the subtopic presented by her will be Daya Gerak Yetrik. Okay, who missed out the class, you may visit the channel of Cikgu Rosemawati to get the lesson. And another class will be Form 4 DLP. So the class will be conducted in English and BM, and here on every Friday, every Sunday, 8:15 p.m. And in the line here, we have few students. Okay, so few supporter. Okay, we have Jiaying. So Kawabai Jiaying, and we have Jimmy. Hi Jimmy, thank you for attending my class. And we have also Mei Yi. Hello Mei Yi. Thank you for joining my class. So you may share my lesson to your friends so that more of your friends can gain benefits from my lesson. Any question, you may actually channel to the chat room so that I can explain to you for the parts you don't understand. Okay, so besides that, to let you know, the link Institute Peringkat Kebangsaan will be sent just finish the lesson. So you may fill out the link with any email you are available. So please fill out the link within 30 minutes just after the lesson is finished. Okay, so without further ado, let us start our lesson today. Okay, so today we are going to our new chapter, heats. So for this chapter, you are going to go through 4 subtopics. So today you'll be learn the first subtopic. It will be thermal equilibrium. And in today's subtopic, you are going to learn or understand about 2 learning standards. Okay, so the first learning standard, you need to able to explain the examples of thermal equilibrium in our daily life. Okay. Hi, we have Diva, hello, Kavi, and also Cairo Heng. Okay, so thank you everyone for joining my lesson. So you may tell me where are you come from. Or everyone, thank you for joining my class. Okay, so here, without further ado, so we go for the first comparison between the heats and temperature. Okay, so before we define for the thermal equilibrium, there are 2 terms you are need to able to differentiate them. So there are heats and temperature. So both of the terms seem like quite similar, but actually they are different. Okay, so for the heat, it is actually a type of energy. While for the temperature, it will be degree of hotness of an object. And the unit for the energy will be joule with capital letter. Then the unit for temperature can be degrees Celsius or Kelvin. However, for Kelvin, it will be the SI unit for temperature I want. Okay, and then the heat is actually the derived quantity, while for the temperature it is a base quantity. Okay, so how we can measure the amount of heat? So you can using the joule meter, or you can actually using the calorimeter also. Then for the temperature, you may measure by using the thermometer. Okay, so this is the basically few differences you may use to compare between the heat and the temperature. Okay, so the next here will be the definition of the thermal equilibrium. Okay, so what is the thermal equilibrium? So first, for thermal equilibrium to occur, two objects with different temperature must be come into contact so that the heat can be transferred. So you can see here we have A and B. Both object is touch one another. If I say the object A and object B is not contact with each other, so the heat transfer will be not able to occur. You want? Okay, then from the figure, you can see that during the thermal contact, so the hot object here given as temperature of 90, while the cold temperature it will be 40, so that the heat transfer will be occur with the difference of temperature between two objects. Okay, so you can see the net heat always flows from the hotter object to the colder one. So you can see here, the arrow is from A to B for the net. Okay, however, the heat transfer from the hotter region A to B and colder region to hot region is actually occur. However, the net heat flow is come from the hot to cold. Okay, then here, as a result, the temperature of the colder object increases. You can see colder object referring to 40 degrees Celsius, where will be the object B, increase to 60 if we're referring to the figure showing here. Okay, so while the hotter object, it will be the A, so it will be decreases. So you can see from 90 to 60. Okay, so you can see the temperature at the thermal equilibrium is actually the same for both objects. Besides that, you can see the heat flow from A to B and B to A is actually equal already. So that means that the net heat flow at the thermal equilibrium will be actually 0, I want. Okay. Okay, so here, number 4, when both objects reach the same temperature, which will be 60, showing by the figure at the thermal equilibrium. So the heat transfer between them become equal. You can see the figure 60 from A to B and 60 from B to A. So the net heat flow here will be 0. 60 minus 0 will be 0. Okay. Okay, so at this point, the objects are said to be in thermal equilibrium. Okay, so the condition where the temperature for both objects contact with are at same temperature, so we can classify the condition as thermal equilibrium. Okay, so here, the condition for thermal equilibrium, as mentioned, both objects will have same temperature, where it will be 60, showing by this figure. Then heat flow in both directions, you can see A to B, which is 60, B to A is also 60. So they are actually have the heat flow, but the rate is equal. Then the net heat flow is 0. Okay, so another one, you can see that the temperature at thermal equilibrium is between the hotter object temperature and colder object temperature initially. Okay, so when they reach the thermal equilibrium, the temperature should be between 40 and 90 for the case showing by the diagram here, I1. Okay, so now you understand already. So what is the meanings and the condition for the thermal equilibrium, right? Okay, so how a thermometer measure body temperature is actually one of the application for the thermal equilibrium. Okay, so at this part, I'm going to discuss few examples of the application of thermal equilibrium. The first will be how a thermometer measure body temperature. So first, the bulb of the thermometer, the bulb will be at here. Now this is a bulb of thermometer is placed in the thermal contact with the patient body. So you can look at the figure is put in their mouth, right? Okay, or under the tongue normally. So heat flow will be from patient body, which is warmer, to the thermometer, which is colder. Okay, so you have to give the heat flow is from hotter region to colder region that you want. Okay, then after some time, thermal equilibrium is reached. So we need to take few minutes to let the thermal equilibrium occur, where the heat flow from the body of the patient to the thermometer is equal to the heat flow from the thermometer to the patient's body. Okay, so at this point, both thermometer and body have the same temperature. Okay, so the net heat flow become 0. Okay, so therefore, the thermometer reading shows the actual body temperature once thermal equilibrium is reached. Okay, so this is how you explain during the exam. Or later on, we can discuss few example for the formal SPM question related to the application of thermal equilibrium. Okay. Okay, besides that, the second application here is how food gets cooked in oven. So here you can see this is an oven. The food is put inside the oven. Okay, so that means that the first we have to discuss the thermal contact between the two objects. Okay, so here will be the air. So the air in the oven is in thermal contact with food. So secondly, again, the heat flow you must discuss from the hotter region, which will be the hot air, to the food, which have the lower temperature. Okay, so as heat is transferred, the temperature of the food increases gradually, because the food is initially with lower temperature. When gains heat, temperature will increases. So when the food reaches the same temperature as the surrounding air, so thermal equilibrium is reached. For example, if you set your oven temperature at 180, so your food will be also reach the same temperature. Okay, so that the food will be cooked with the temperature we set. Okay, so at this point, the food is fully cooked and no net heat transfer occur between the food and the air. Or you can see the way I explained to you for different application is actually the same. Okay, so now we go for another application, the last application, how refrigeration keeps food fresh. Okay, so here we discuss about the cooling condition. Okay, so again, we must discuss about the thermal contact between two objects. So here will be the colder air in the refrigerator and the food we put in the fridge. Okay, so the food inside the refrigerator is thermal contact. Thermal contact, that means both objects is contact with each other, is touching each other. Okay, so with the cold air in the refrigerator. So the next you should discuss about the heat flow from hotter to colder region. Okay, so hi, here we have another two students join me here. Okay, so we have Huishen. Again, Jimmy, thank you for your response. So that I know you are there. Okay. Okay, then heat flow from the warmer food to the colder air. So as a result, temperature of the food decreases gradually. So that means that the food is actually lost the heat and the temperature will be decreases. Okay, so eventually the food and the surrounding air reach thermal equilibrium where both objects, the colder air and the food, have the same temperature. Okay, then this lower temperature slow down bacterial activity, keeping the food fresh for a longer period. Okay, so this is an application of the cooling effect from the refrigerator in the application of thermal equilibrium. Okay, so we have finished already our first learning standard. Okay, so here I prepare few objective question for the learning standard 1. Okay, so you might share your answer in the chat room Okay, so let me read the question first. Okay, so the diagram show two copper block L and N touching each other. the initial temperature of the L is 50. Okay, so here is 50 degrees Celsius and M is 30 degrees Celsius, respectively. Okay, so which statement is correct when L and M are at thermal equilibrium? Okay, so for thermal equilibrium, just now I mentioned to you, there will be few conditions you must meet. So the first, no net flow heat between them. So that means the heat from L to M and M to L is the same. So two objects in thermal equilibrium have the same temperature. So in one more will be the temperature at the thermal equilibrium when they reach will be between 30 and 50. If you calculate or you give the expectation of the thermal equilibrium condition, so the temperature you give must be above 30, below 50. Okay, hi, Yuchen. And NH Han, so thank you for joining my lesson. Okay, so Jimmy give D. Okay, so we check whether the answer from Jimmy is correct. So others also may show your answer in chat room. Okay, so we look at the D answer, whether the answer from Jimmy is correct. Net rate of heat flow between L and M is 0. Okay, I also think that this is supposed to answer because here already tell us the net heat flow is 0. Okay, so answer is D. Okay, good. Or Jimmy to get the correct answer. Okay, so the first statement, why is wrong? Temperature of L is higher than M is wrong. When achieve thermal equilibrium, they will be at same temperature. Same temperature. Okay, then the quantity of heat in L is same as in M. Actually, it's wrong. Although the final temperature for L and M is the same, example is 40. However, the L with greater mass, has greater heat. Please take note for this. So if two objects have the same temperature, so their contents of heat actually different, depends on the mass. If the mass is greater, heat will be supposed greater. Okay, so here L is actually greater than M when achieving the thermal equilibrium with same temperature. Okay, so rate of change of temperature, okay, so here will be equal already because the temperature will be 0. Temperature will be same. All I want. So answer is D. Okay, good. Response from Jimmy. So others also may show your answer in the chat room. Okay, so the next question here. Diagram 12.1 shows hot water being poured into cold syrup. Okay, that this is a cold syrup and we have a hot water pour or mix together. Okay, then the final mixture will be at 12.2. Okay, so what is the correct? What statement is correct about the temperature of the final mixture? Okay, so final mixture again, they should achieve the thermal equilibrium already, right? Okay, so the tips here. When hot water mixed with cold water, temperature of the mixture must be between temperature of hot water and the cold water. This is what I tell you just now, right? Okay, so because the hot water will be lost heat and the heat loss will be gained by the cold syrup here. So the temperature for the cold syrup increase, then for the hot water will decrease. Then both should be achieved the same temperature at the thermal equilibrium you want. Okay, so here, A, it is lower than the temperature of cold syrup. Lower than is wrong, right? You want. So suppose cold syrup you want, right? Because the temperature at final is between temperature of cold syrup and hot water. Then B is lower than the temperature of hot water. Okay, so here, Jimmy give D. Okay, just like I mentioned, the hot tips here, right? So the temperature must be lower than hot water, right? Then higher than cold syrup. Okay, so that the final temperature is between them. For example, hot water is 90. Then the cold syrup is, example, 5 degrees Celsius. So the end or the mixture final will be between 5 and 90. So must be lower than hot water. Okay, so Jimmy, suppose, I think the best answer here will be B. It is higher than the temperature of hot water is wrong because must be lower, must be between cold and hot water. It is the same as the temperature of cold syrup. Here is also wrong actually, Jimmy. Okay. Yes, this is V. Hello. Oh, HN Han is known as Darwin, is it? Okay, how? Okay, hi Darwin. Okay, so Jimmy give the B. Okay, yes, answer should be B. Okay, it's between hot and cold syrup. Okay, so now we go for the third question, the last question for Learning Center 1. Okay, then after that we go for break, then we come back for Learning Center 2. Okay, so diagram 11 shows hot water being added to cold water. So this is quite similar to just now one, right? But the option you can see is different. Okay, so which of the following statement is correct if there is no heat losses to the surrounding? Okay, so here, heat lost by hot water is less than heat gain by cold water. Okay, so here, because the question tells us already, so there is no heat loss to surrounding. Okay, so that means that there will be no heat loss. So that means the heat gained by the warm water, heat will be gained by warm water. So it's come from the heat loss from the hot water. Okay. Hi, Darwin. Mingyang, hello. So JY12, wow. So, and we have also Kaviya, is it? Okay, Kaviya, hello, Kaviya. And also Yuan. Hello, Yuan. So you may tell me where I come from. Okay, some of you, I think is the first time join my lesson, right? So please let me know where I come from. Okay, hello, Tiva. Okay, so here, what is the answer supposed to be in one? A, B, C. Okay, I read the answer first. The first, I read the option first. The first, heat loss by hot water is less than heat gain by the cold water. B, heat loss by hot water is greater than the heat gain by cold water. Heat loss by hot water is equal to heat gain by the cold water. Okay, so what is supposed to be the answer? If you look at the hot tips, when there is no heat loss, that means that heat gain by the warm water will be supposed equal to heat loss. Yes, I see the answer from Jimmy already. Okay, so it's correct, Jimmy. So answer is C, in one. Okay, so now we are going to take 5 first. Okay, so please stay tuned because the next will be the Learning Center 2, where will be the popular question going to discuss at this section, Learning Center 2.1. Okay, so we take 5 first. Okay, so come back very soon. Welcome back to Learning Center 2. So this will be the last Learning Center for today's subtopic. So the Learning Center 2, you must able to calibrate liquid in glass thermometer using 2 fixed points. Okay, what it means by the calibrate? Okay, so here, liquid in glass thermometer. So thermometer is the instrument where we use to measure the temperature. I think most of you should be know, right? Okay, so thank you, Kushesh and Kaishen. Okay, Kaishen, welcome to join my class. Oh, you're Jimmy's friend. Okay, so thank you, Jimmy, for recommend my class to your friends. Okay, so let us continue. So here, 2 common types of liquid in glass thermometer. Okay, so basically, I think you should know already. So mercury and alcohol thermometer is 2 common thermometer we use in the laboratory, right? Okay, so here, so the advantage of using mercury as a thermometric liquid. Okay, so why we choose mercury or alcohol as a thermometric liquid? So here we have few reasons and going to ask at the section C or B for the multiplication question or the decision making question. So later on, we have one section B question related to this topic or Learning Center 2, so we can learn together later on. Okay, so the first will be the high boiling point for the mercury, which is about 357 degrees Celsius. So it's suitable to measure for high temperature. So if for alcohol, they have a low boiling point, which is about 78 degrees Celsius. So that means that alcohol is not so suitable to measure the temperature, which is greater than 78. So that means that mercury will be more suitable to measure for the substance with higher temperature, which will be greater than 78 degrees Celsius, right? Then the second, the melting point is lower, as low as negative 39 degrees Celsius. So allowing measures at low temperature. However, if let's say we compare to the alcohol actually can measure more lower temperature because the low melting point for the alcohol is about negative 114. So the alcohol is suitable to use to measure colder substance. Oh, you want? Oh, Jimmy is very clever. Okay, so let's learn together here. So each other will become clever and smart. Okay, so the next will be mercury is a good conductor of heat. So ensuring quick response to temperature changes. And then the next will be expand and contract uniformly, giving accurate reading. Then the mercury is also opaque, making the mercury column easily visible. Then the last reason we use mercury is because it has high cohesive forces. So mercury does not stick to the glass wall. Okay, so here we have about 6 reason or advantages by using the mercury. Okay, hi, Tabin. Okay, so the next will be regarding how we can increase the sensitivity of the mercury thermometer. So what means by increasing the sensitivity of mercury thermometer? Here that means that when there is a slightly changes of the temperature, the mercury thermometer will able to detect. Okay, so how we can increase the sensitivity? Here we have a few reason. Okay, so the first a few method. So the first will be reduce the thickness of the glass bulb. Okay, so if you look at the thermometer diagram here, so the bulb will be at here. Okay, so the glass thickness at the bulb should be thinner so that the sensitivity can increase. So where the heat transfer will be easily to occur. Okay, you can see here, a lot faster heat transfer between environment and the mercury. So this is how you give your reason for your section C or B. Okay, then the second, use the smaller diameter or capillary tube. Okay, so the capillary tube will be here, you can see. So the capillary tube must have smaller diameter. Okay, because you see, a narrower capillaries causes the mercury column to rise more for same volume expansion. Okay, so making changes in temperature easier to observe. Okay, then the last here we have another way to increase the strength of the thermometer, make it more harder to break. Okay, so we have to use a round and thicker outer glass over here. The outer glass should be round and also thicker. So this can increase the strength. Okay, actually can increase the strength of the thermometer so that it will be not break easily. Another will be can magnify the mercury column so that we can read the reading more easily. Okay, so this is the reason for round and thicker glass we want. Okay, then now we go for the thermometer calibration. Okay, so just now I have asked you what means by calibration, right? Okay, so here, the calibration or calibrating a thermometer is meanings by marking the scale accurately so that the thermometer reading can be correctly interpreted. Okay, so you can just look at this figure. So the thermometer is without any scale. Okay, so this is uncalibrated thermometer. Okay, so how we can calibrate our thermometer? So you should use two fixed point. Okay, so here you see. So to do this or the calibrating the thermometer, firstly you have to choose fixed reference point. Two reference points are chosen to mark the thermometer scale. Okay, then this point must be easily reproducible and accurate. Okay, so reproducible, that means that the 2-point example, actually we're using the boiling point of water, boiling point of ice and boiling point of water and the melting point of the ice. Okay, so the temperature for melting point of ice and the boiling point of water is always fixed, can easily to produce the same reading now. Okay, then as mentioned, commonly we use the ice point for the pure water, which is 0 degrees Celsius, and the steam point or pure water, which is 100 degrees Celsius, as the reference point we want. Okay, so here, the procedure for calibration of thermometer will be like this. So first, you can see, you have to place the thermometer in the pure melting ice and allow it to stabilize. Okay, so mark the mercury or alcohol level as L0. Okay, L0 represent the 0 degrees Celsius. Okay, so this is known as the ice point or lower fixed point, as mentioned just now. Okay. Okay, then the next here will be place the thermometer in steam from boiling pure water and wet until reading stabilized. You can see here. Now, the thermometer is placed at the steam. So when we'll be achieving the 100 degrees Celsius. Okay, so you mark the level as L100. Okay, so this is the steam point or upper fixed point. Okay, so this is so-called the two reference fixed point, just now I mentioned to you. Okay, so in the line here we have Jadis, is it? And Cikgu Hasnitah. Okay, so thank you for joining my class. Okay, so here I continue. So after we get these 2 points, where will be L0 and L100, so you have to divide 100 equally. Okay, so the distance between L0 and L100 is divided into 100 equal division. Okay, so each representing 1 degree Celsius. Okay, so others temperature reading can now be interpreted for this scale. So that means that So when we get L0 and L100, we divide 100. So every degree Celsius will be able to get through the division we make. Okay, so the formula for this formula, L theta, that means that will be the temperature we're going to measure or determine. Okay, so we have the length we know as L0, L theta, minus the length from the bulb to the point where we mark as L0. Okay, is 0 degrees Celsius. Okay, then over L100, so L100 will be the length between bulb to the L100. So minus L0 times 100 degrees Celsius. Okay, so this will be how we get the temperature we're going to measure. Okay, so later on we have a few example question for practicing the application of this formula. Okay, so now we actually already finished discuss the contents of Learning Center 2. So here we have another 2 questions. So here we have going to learn together the example question for section A. Section A for paper 2 and another one will be section B for paper 2. Okay, so again, you may share your answer in the chat room if you want. Okay, so here diagram 3.1 shows an uncalibrated thermometer used to measure the temperature of hot water in the beaker. Okay, so first ask you the meanings of thermal equilibrium. Okay, so just now I have go through with you already, right? So basically, this will be the definition you can give during the exam. So when 2 objects are in thermal contact, make sure you give this thermal contact, net heat flow is 0 and the temperature of the both object is equal. Okay, so this is the 3 keyword you have to give for the definition of thermal equilibrium I want. Okay, then the second question will be, okay, so this is the calculation I want. Okay, so you can prepare your calculator. Okay, so for calculate the temperature. Okay, so given the length of the mercury column of the thermometer at 0 degrees Celsius is 2 cm, where we have the symbol L091, and the length of the mercury column of thermometer at 100 degrees Celsius, L100 is 18. So you can look at this figure. Okay, so this is a sample question from trial 2024 from State of Kedah. Okay, so now the question asks about the temperature when the water is at Lx 14 cm. Okay, so what is the temperature of the hot water? So you can apply this formula. Okay, so substitute the theta as x. This will be Lx, right? Okay, so the L0 given as 2 cm. L100 will be 18. Then L0 again will be 2 cm. Okay, so you multiply with 100 degrees Celsius. Okay, so what suppose the answer for the temperature of the hot water? 12 over 16. Yes. 12 over 16. Yes, because here is 14. Yes, good. So that means that above will be 12 over 16 times 100. Yes, good. So this will be the step. 14 minus 2 is 12. Yes, Jimmy, you are correct. Okay. Then 18 minus 2 is 16. Then times 100. So what is the temperature supposed to be? Three over 4, you simplify. Okay, so we will get yes, good. Okay, so you will get 75 degrees Celsius. Okay, so really smart, Jimmy. Okay, so your answer is correct. Okay, so now we go for the next question, everyone. Okay, so here will be the discussion. Okay, so it's a theory question. So the water is left. Okay, so I zoom in the question. Okay, so the water is left until it reaches the room temperature. So by using appropriate physics concepts, explain the situation. Okay, so you can see. So the water initially is hot. Okay, so must be explained with thermal contact, right? First. Okay, so the hot water must be thermal contact with the surrounding air, right? Okay, so this will be the first point. The air from surrounding is in thermal contact with water. Okay, however, here we only have 2 marks, right? Sometimes we're not sure that the answer you give is within the scheme, right? So you can write more than 2 marks. This is what I advise you. Okay, so second, the net heat is released to surrounding. Okay, because hotter object will be water. Then the air surrounding will be colder. So the net heat will be released to surrounding. Okay, then the M3 temperature water will be decreases because it lost the heat. Okay, it lost the heat to surrounding. Okay, then the next will be eventually the water and the surrounding air reach thermal equilibrium. So the temperature surrounding and the water will be the same, which is at the room temperature. Okay, so you can see because of temperature decreases, average kinetic energy of water decreases. Okay, because the temperature is actually measure the average kinetic energy of particles. Okay, so if the average kinetic energy is higher, so the temperature will increases. Okay, so the scheme answer is actually mark number 2, number 3, and number 5. Okay, so however, the maximum mark will be 2 marks. So you can write whatever you think is actually related. Yes? Okay, so any question you all can just ask in the chat room. Okay, so now we go for the next. Okay, so here, this will be actually the last question for today's, but this is a 20 marks question, and this is a section B question. So we're going to discuss one decision-making question, 10 marks question related to selection of the suitable thermometer. Okay, so here, diagram line shows a clinical thermometer that was placed under the tongue of a girl who has fever. So the clinical thermometer works using principle of thermal equilibrium. Okay, so what is the meanings of temperature? Okay, so the temperature meanings actually we discussed already at the first slide. Okay, so it's actually degree of hotness of an object. First mark is normally definition or concept physics. Okay, then the second mark. Okay, so here we have the 4 marks theory question explanation. Okay, so here 4 marks, you have to give minimum 4 points. Again, you have to write more than that, but the answers should be not contra. Okay, so here the first mark again, you have to discuss about the thermal contact, right? So here the bulb of the thermometer is placed in the thermal contact with girl's body. Actually, here will be the tongues of the girls, right? Okay, but here is using body temperature. Okay, so we just follow. Okay, then second mark, we have to state the heat flow is come from the hotter region to colder region. Okay, so the hotter region will be the girl's body, and then the colder place will be thermometer. Okay, then after a while, the thermal equilibrium will be reached. Okay, so where we have 2 conditions, you have to discuss the net heat flow with 0, and then the temperature for both objects here will be the same. Okay, so at this point, both thermometer and the body have the same temperature. You can see this is what I mentioned to you, and the net heat flow becomes 0. This is the second condition you have to state in your answer. Okay, then Therefore, the thermometer reading shows the actual body temperature once thermal equilibrium is reached. Everyone. Okay, I think you should know how to write already, right? Okay, so now we go for the calculation question. Okay, so here actually we have two calculations. Okay, so the first, okay, I read the question first. So a thermometer which not calibrated has a mercury column of length 28 cm. Okay, so it should be L100, right? When the temperature is 100 degrees Celsius. Okay, so the mercury column is 14 cm when put in the liquid P. Okay, so determine the temperature of the liquid. Actually, if let's say we're using logical thinking for this question, suppose you also no need to substitute in the formula, right? Okay, you see 28 cm is a length of the column of mercury for 100 degrees Celsius. So 14 is actually half of the 28, right? So actually you can straight away to give your answer. However, you can see here 3 marks. You should also substitute in the formula. So when the question here not give you the 0 degrees Celsius, right? Okay, so here if 28 cm divide 100, so actually the L note here we use 0 degrees Celsius, everyone. Okay, so we're using 0 actually. So 14 minus 0, 28 minus 0, so we get 50 degrees Celsius. Okay, actually, if logical thinking here, 28 is 100, 14 is actually half of 28, right? So suppose you have to get 50 also. Okay, then the next question here asks you to convert the degrees Celsius to Kelvin. Okay, so here again, you should plus 273. Okay, plus 273 so that you can get the 50 degrees Celsius in the Kelvin. Okay, so when we plus 273, you get 323 Kelvin. Okay, so this is an example of the trial question also. Okay, so the next will be the last question of the day. Okay, so this will be the decision making question. Okay, so you can go through the table. Okay, so you can tell me what should be the thermometer you are going to choose for this application. Okay, so I read through the question first. Okay, so diagram 9.2 shows the design of thermometer. Okay, so table 3 shows the characteristic of 4 thermometer. So we have J, K, L, and M. So you are required to choose a suitable thermometer to measure the temperature of material used in school physics laboratory. Okay, so we should choose the range for thermometer used in laboratory. Okay, then give your reason for your choice. Okay, so here, first we look at the range. So the range given here, we have 0 to 100, 30 to 45, 30 to 45, 0 to 100. Okay, so which one we supposed to choose? Okay, so if just now I tell you already, the keyword here is actually the school physics laboratory, right? Okay, so here we should choose the range which is wider, or is at 0 to 100. You want J. Okay, so fast response from Jimmy. Okay, so option from Jimmy is J. So how about others? You can share your answer in the chat room also. Okay, so Jimmy give J. Okay, let's see together. Okay, suppose my correct one is here, because the first one we have to choose 0 to 100, right? So if 30 to 45, suppose this will be the clinical thermometer, or we use to measure body temperature. So definitely it's out already. So you can just cancel out these two options. Okay, so we go for the next. Diameter, just now actually we discussed already. We should choose the smaller one, right? Which will be able to increase the sensitivity of the thermometer. Okay, so that means that answer from Jimmy is actually correct. Okay, so the another two options here, we have choose 0.1. So 0.1 actually is higher accuracy compared to 1. Okay, so where will be given us more accurate answer. Then the next here will be mercury. Okay, why mercury, not alcohol? Okay, so just now actually I have discussed with you the melting point and boiling point for both material here. So alcohol is 78. Then the mercury can up to 300 plus. Then the, sorry, I think I reversed already. I reversed already, Okay, so this should be boiling, boiling point. Boiling point should be higher. Okay, so this will be the melting point, Okay, so melting point for mercury is negative 38. Okay, so it's within the range we want. Okay, so answer from Jimmy, J is correct. So here we not use alcohol for our option here. Okay, we choose mercury, Okay, so we choose J, yes, correct. Okay, so here we look at the reason one by one. Okay, the first, just now we explained already, so we should choose the bigger range, which is between 0 to 100. So reason can measure at lower and higher temperature, or you can measure the melting point of ice and boiling point of ice, boiling point of water. Okay, so this is what the common measurement of temperature we conduct in the laboratory. Okay, then the second, the capillary tube should be small, or the diameter should be small. Okay, so that the sensitivity can be increased. Okay, and then can detect small change of temperature. Also you can give the answer. Then the next, the accuracy should be higher, or we choose 0.1. But normally we preferring students to give the terms more than the numbers. Okay, so here more accurate, more sensitive, can detect small change. Okay, so this is an advice reason for this aspect. Okay, then the mercury will be going to use, just like I mentioned to you already. Okay, so here we actually can also give the, just now we discussed already the 6 advantages of using the mercury as a liquid in glass tube thermometer, right? Okay, so you can give even expansion or contraction or pack to not stick to the glass wall. So all of this is accepted. So that means that you can give any suitable characteristic of the mercury for your answer. Okay, then the last you have to keep J. Yes. So Jimmy answer again, correct? Okay, it's J. Okay, so again you have to copy 1357 is what? It will be this. Bigger range, small capillary tube, high accuracy, and then mercury you are going to use. So this should be the way how you give your answer in multiplication question in section B. Okay, so that's all for the lesson today. Okay, so I hope that you can gain benefit from my lesson today. Okay, so now I would like to share the link schedule in the groups. Okay, so you all may fill up the link schedule with any email you are available. Okay, please fill up within 30 minutes, just after the live in letter. Okay, again, please click like and share link of the day for your friends so that more of your friends may get benefit from my class today. Okay, so thank you also, Jimmy, for joining my lesson and recommend my class to your friend. Okay, so don't forget to follow the next physics classes, which will be every Friday for non-DLP Form 5 class. Here on every Friday, 9:30 p.m. And then another class will be DLP group for Form 4, which will be here on every Sunday, 8:15 p.m. Okay, so that's all for my sharing today. So thank you everyone for joining my lesson. Okay, so bye-bye.